These are the questions on Castle Learning. All right. So first question says a ball is thrown straight downward with a speed of zero point 0.5 meters per second from a height of 4 meters. So your initial velocity, you're throwing it straight down, and because it's going down, your velocity value is negative. All right, so it's negative 0.5 because it's going downwards. And so it says your height is 4 meters, sure, but we're just going to ignore that for now. And so what is the speed of the ball? 0.7 seconds after it is released. So time is 0.7 seconds. There's something else we know because if we throw something down, we know that our acceleration is negative 9.8 meters per second squared due to gravity, right? Gravity is pulling you down and the object is accelerating at negative 9.8 meters per second squared. And so we want to find out what is the speed of the ball after this amount of time. So we want to find out what our final velocity is. Now, the reason why we ignore the height of 4 meters is, again, if we take a look at this and we start at our 0 point, this is our line, and we go downwards, say this is like 4 meters, 4 meters, right? 4 meters. It's 4 meters, sure. 4m. This is 4 meters. Now, it doesn't take 0.7 seconds for the ball to drop the whole length. Maybe it takes like maybe around half a length. It drops 0.7 seconds. It takes 0.7 seconds to drop maybe half a length. Again, this is hypothetical. I don't know actually unless I calculate it, and I haven't calculated it. And let's say to drop this whole distance, it takes longer than 0.7 seconds, maybe like around 1 second or so, right? Again, I'm estimating it. I don't actually know the amount of time it would take to drop that distance, but let's say it takes 1 second. And so that's why you ignore this displacement value over here. We don't use it because the question is only asking what is the speed after it has traveled this amount of time, not this amount of time, only this amount. So if you were to use this displacement value, you get the question wrong. You get the answer wrong. All right, so let's actually solve it now. And so we get VF is equal to negative 0.5 plus negative 9.8, 0.7. And then once you add all this up, you should get a negative 7.4 meters per second. But the question is asking what is the speed? Speed is a scalar. Okay? Speed is a scalar. And your velocity is a vector. So since speed is a scalar, we don't care about this negative sign. So we're going to answer the question. The answer to this question is number 2. Now, let's go to number 2. So here and again in this question, we're not going to bother with the 25 Newton weight because that's irrelevant. That's an irrelevant information. You don't need to know what you will learn what newtons are soon enough, but not right now. We don't really care about it. So we're just going to ignore the 25 newtons. So it says falls freely from rest. And so you know your initial velocity is 0 meters per second. And so what is the total distance the wave falls in the first 1 second? And so you know your time is 1 second. What else do you know? Because it's falling, we know that acceleration due to gravity is negative 9.8 meters per second squared. Alright, so they want to know what your total distance is. And for the most part, we're always going to assume this is displacement, unless stated otherwise. So now we're just going to solve it. This is the formula we use. Because again, this formula has all the variables we need, and we don't have VF, so we're going to use this formula instead. 0. 0 times anything is 0, so I'm going to ignore the t. And now I get negative 4.9. 1 squared is 1. So we can end up with an answer of negative 4.9 meters. But the question again is asking for distance, and distance is a scalar. All right, distance is a scalar. So we're not going to care about the negative sign at all. All right, we don't care about the negative sign at all. Oh man, that's a terrible C. All right, well, the answer is 3. And so number 3, again, we kind of did this with demo in class on Thursday. If you were to be on the moon and you dropped the baseball on the balloon at the same exact time, which would fall? What does the astronaut observe? And so in the absence of air resistance, which again the moon has no air, has no atmosphere, all objects fall at the same rate, no matter what amount of gravity, acceleration to gravity there is. Regardless of whether or not the gravity on the moon is less than the gravity on Earth, they both fall down at the same rate. And so the baseball and the balloon fall at the same rate, number 3. If you need, but that is the idea, right? Objects like a flat piece of paper, they fall slower because of air resistance, because the flat piece of paper is hitting those hidden air atoms as it falls down, and that slows the paper down. It's called air resistance. So his answer is number 3. So a baseball dropped from the roof of a tall building. Again, it's dropping, so we know that our acceleration due to gravity is negative 9.8 meters per second squared. And so the baseball takes a time of 3.1 seconds to hit the ground. So once again, what else do you know? Well, you also know that your initial velocity is 0. Right? You're dropping it. We can assume that you're dropping it. If it doesn't say otherwise, we can say it dropped from rest. So how tall is the building? So you want to know the height. So we have this. So D is equal to 0. 0 times anything is 0. So I'm not going to substitute for T. 0, negative 4.9, 3.1 squared. I'm just going to round it to 9. I'm just going to do 3 squared and get around 9. And I should get somewhere around 45. Right, I should get somewhere around 45 meters. And so, perfect. There's an answer close to 45 meters, and the answer is 47 meters. Okay, so it is 3. The answer is 3. Now let me go to. So that concludes the free fall homework. Um, let's go through. Hold on. Let's do the. Let us do the extra practice one. So this one says was speed of a 2.5 kilogram mass. Again, the mass here doesn't matter. We haven't really related it to anything. So what is the speed? So you want to know what the final speed is. Final velocity. After it's fallen freely from rest, so we know it's falling. And so you can automatically assume that, well, my acceleration is negative 9.8 meters per second squared. From rest, it falls from rest, so you know your initial velocity is 0. And you know your distance is 12 meters. So you know your displacement is negative 12, right? So it's dropping, it's going down. Why is it negative 12? Because again, you're dropping from a zero, right? You're dropping from zero, so you know anything below zero is negative. So it dropped a distance of 12 meters. So your displacement is negative 12 meters. So you solve for this, you're going to do VF squared. That's a 2, no matter how poorly it's drawn, plus 2AD. Again, we want to know what VF squared is. So VI is 0 plus 2, negative 9.8, 12. And we should get VF squared is equal to 24, 200, to around, somewhere around 240. Somewhere around 240. All right, meters per second, meters squared, second squared. So somewhere around 240. All right, and then we want to square root this. Again, I'm just estimating right now. If you're doing on a calculator, you get an answer very similar to 240, somewhere around there. We square root both sides, and we're going to get somewhere around 15. Okay, we're gonna get somewhere around 15 per meters per second. And so the answer is number 2. All right, 15 meters per second squared. Yes, is correct. I just take a lot of shortcuts. So on the test, I would not suggest doing that. I would suggest doing all your work, showing me all your work, just so that I know that you understand what's going on. Let's actually erase this too. So number 3, a ball dropped from rest. It's dropping. Assume that negative 9. Assume that it's negative 9.8 meters per second squared. Dropping from rest. You know that's 0. Hits the ground with a speed of 20 meters per second. So you know your final speed is 20 meters per second. So the time during which the ball is in free fall is approximately what? So how do you solve it? You use this 20, 0 plus negative 9.8 t divided by negative 9.8, and you're gonna get somewhere around negative 2 seconds. Did I do something wrong? Oh yes, I did do something wrong because I forgot to put that your final velocity is negative 20. So we do get a positive 2 seconds. It all works out. So we do get number 2. So the answer is number 2. Number 3. Rock falls from rest. It's falling from rest, so you know it's 0. It's falling, so you know A is negative 9.8 meters per second squared. How far has the rock fallen? So you want to know your displacement, or rather your distance, and we know its final speed is 39.2 meters per second, so it's negative 39 because it's going downwards. So you set all this up. The only equation we can use is this, because again we're missing, so negative 39.2 squared is equal to 0 squared, which is just 0, to negative 9.8 d. I'm just gonna round this to 40. So 40 squared is, I'm assuming 40 squared is this. I'm assuming that's how much 40 squared is. It should be. It should be. Yeah, this is 40 squared, around there. So around 1600. And then you get negative 20. And again, I'm rounding it. I'm rounding it to negative 20d. divided by -20, divided by -20. So your displacement is divided by 280. So your displacement should be around -80 meters. All right, so the answer is number 3. Yep, the answer is 3. All right, a 1 kilogram ball, that's a mass, we can ignore that, is dropped. So you know that acceleration is -9.8 meters per second squared from the roof of a building 4 meters high. So we know our displacement is -40 meters. What is the approximate time of fall? We can assume that our initial velocity is 0 because it doesn't say otherwise. It's dropped, so we can assume that it's dropping from rest. All right, so we can say that d is equal to VIT plus 1/2 AT squared, -40, 0 plus 1/2 -9.8 t squared. So -40 is -4.9 t squared. Divide both sides by -4.9. Divided by, it's going to be somewhere around 5. So you want to, so it is square root of 5. So it's going to be somewhere like around 2.9. Okay, if you ever do the square root of 5, you're going to get, well, if you ever do this, let's do this properly. All right, let me get my phone out. -40 divided by -4.9. Oh, right, okay. I know, I see. It's definitely not 5. I don't know how wait, I don't know why I thought it was 5. Oh, right, I rounded this to 5 and then put 5 down here. Instead of doing 40 divided by 5 is 8. So you get somewhere around 8, alright? So you do get somewhere around 8. And so if you square root both sides, if you square root 8, you should get somewhere around 2.9. Because answer number 2 doesn't make sense. 2.0 seconds squared is 4. 4.1 seconds squared is 16. So the midpoint kind of works. So it's like around 2.9 seconds. And so the answer is 1.